Hello everybody, today we're doing LeetCode 128, longest consecutive sequence. Given an unsorted array of integers called nums, return the length of the longest consecutive elements sequence. You must write this algorithm that runs in O of n time. For example 1, the input for the array will be 104, 200, 132, and we expect the output to be 4 because the longest possible sequence that we can find in this array will be 1, 2, 3, and 4. For example 2, we expect the output to be 9. Let's say we were to sort this, and we can, then we can just count the longest possible sequence, which is 0, 1, 2, 3, 4, 5, 6, 7, and 8, which equals to 9 digits. So that's our longest possible sequence. So let's see how we would go about this. We know we have our array that is unsorted, and we're not allowed to sort because we're given the constraint of having this run in O of n time. Sorting would take it to n log n, and that it would make our algorithm run slower, so we don't want that. So let's think of a way to make this run in O of n time. One way to go about it is to create a hash set. So we're going to create a set. We essentially just take this entire array and convert it into an object called a set. The neat thing about sets is that it'll remove any sort of duplicates automatically when you're iterating through it because it only stores unique values. So we have this object called a set, and it'll look just like the array. But the neat thing about it is because it's a set, it'll have a really quick lookup time, which is O of 1. So what we can do here is we can actually iterate through nums, and then as we iterate through nums, we're going to use our set as a reference. It's kind of like a dictionary. We're going to just double check or reference it as we go. So as we iterate through nums, what do we really want to do? We want to figure out where the beginning of the sequence is. Because if you're at the end of the sequence, it's not that easy to get a count. But if you're at the very beginning, like if you find that 1 is the very beginning, then it's very easy for you to go into the set and look up the next numbers and then have a count at the same time. To start, we're going to have our max variable set at 0, and then within the while loop that we're iterating through, we're going to have our count set to 1. Because if we find the beginning number, that means that number is already part of our sequence. So to illustrate, let's say I is here. When the index is at 0, the value is 100. And we go into our set and we see if there's a 99 in here. Because if there's a 99, that means that the sequence would look like this. And there's no way that 100 could be the very beginning of our sequence. We definitely want the beginning of our sequence so that we can keep a log of count. So now I gets incremented by 1, and our value is 4. And we want to look for a number that is 3, because we are trying to see if this number is the beginning of our sequence or not. If it's at the tail end of our sequence or in the middle, we want to keep moving on. And we see that there's a 3. That's not good for us. We're looking for the beginning here. So we're going to increase the I by 1, and now we're at 200. At 200, we look into our set, and we're looking for the number 199. You don't see that in there, no big deal. So we're going to increase I by 1, and the value is 1. So now our value equals 1. We want to look into our set, make sure that there's no 0 in there, and there's not. So we know that we're in the beginning of a possible sequence, right? So the next thing that we do is we're going to look to see if there's a 2 in the set. And we see that there's a 2. And we're like, okay, that's great. There's a 2. Let's increase our count to 2. Our value is now 2. So now our current value is 2, but we want to see if there's another number in there, which is 3, because that would elongate our sequence. And we see that there's a 3 in there. That is so great. So we'll increase our count to 3. Our value is now 3, and we want to see if there is another number in there. That is a 4. And we see that there's a 4. Awesome, great. Count now increases to 4. And our value is 4. And we are looking for a 5. We don't see that there is a 5. So now that we have this final count of 4, what do we want to do to max? we're going to do a math.max and compare the two values, 0 and 4, and see which value is greater. And at the very end, that's what we'll return. So right now, max is 4 because 4 is greater than 0. And this will keep iterating. I will keep iterating through the loop. It'll continue to find any beginning of a sequence. And then when it does, and it has a count, it'll compare the two values for count and max, and then finally return whatever is greatest. And in this case, it's 4. So let's see what this would look like in the code. Okay, the first thing that we are going to do is create our set. So const set equals new set. And then we want to add all of the elements inside our nums array into the set so that we can use the handy dandy lookup, which is constant time lookup. So for const num of nums, set dot add num. Then after that, we want to create our max variable, and then we're going to loop through our original input, which is our array call to nums. 0 and I is less than nums.length, plus val nums sub I, just so that it's easier to read. And we're also going to have our count equal to 1 in the beginning, because once we figure out the number that is the beginning of a sequence, that is already our count. And then we're going to go to our dictionary, our reference, our lookup, our set, and find the corresponding numbers to create a sequence. So after that, what's the next thing we want to do? Well, we want to make sure that we are not in the middle or the end of our sequence. We definitely want to make sure that we find the very first number of our sequence to get count going. So in order to do that, we're going to do set.has and just check, is there a number in there? For example, if I is at a value that it's 100, we're going to check does set have the number 99 in there. And if it does, cool. Let's just go ahead and continue because we want nothing to do with it. After that, that means the number we have is the beginning of our sequence, right? Like once we found the very first number in our sequence, we want to make sure to start counting. So we're going to check our set. So while set.has ++ val, we're going to go ahead and increase our count. I just wanted to note that this prefix operator ++ val, that means that it is going to change this number first before the set.has happens. So for example, if val is currently 3, that means that this ++ val will change it to a 4 first, and then it'll check the set.has 4, and if it's a yes, it'll be like, okay, cool, then let's increase the count. So that's what that does. After we get the entire count for the longest possible sequence in that moment, then we're going to do a math.max on max. We want to update our max every time we get a new count with the greatest longest possible sequence. Max equals math.max count max. And at the very end, we'll return max. So let's run our sample test cases. That looks good. And there you have it. That's a way to go about it. So let's talk about time and space complexity. We've created our set, which is O of n time. And then after that, we've iterated through the original input, which is also O of n time. But because these for loops or these loops are happening separately, the overall time complexity will be O of n. In terms of space, we're creating the set. So for space, it'll also be O of n. So there you have it. That's how you could go about it. If you liked the video and would like to see more, please help out by liking and subscribing. Thank you so much. See y'all next time.